All right. Here's problem 16 from the Unit 1 example set. This is Mr. Kingsbury, and I'm going to walk you through it. Once again, much like problem 15, I've noticed that outside of my bars, which are on the left side, there is a number. That I've got to get rid of that before I can do anything with the bars. So the first thing I'm going to do is subtract 11 from both sides. So that gives me the absolute value of 3x plus 7 on the left, and on the right, that gives me 22. Now from here, I can divide it into my two equations. One of them will be the 3x plus 7 equals 22, just like it says, but without the bars. The other one will be 3x plus 7 equals negative 22. Now I need to solve both and check both. So let's start with this one. 3x plus 7 equals 22. My first step is to subtract 7 from both sides. I get 3x equals 15. And then I will divide both sides by 3. I get x equals 5. We'll check that in just a minute here. Here's hoping. Let's do the other one. So I will also subtract 7 from both sides here. This gives me 3x equals negative 29. And if I divide both sides by 3, I end up getting a pretty nasty decimal. It's actually 9.66666. I'm sorry, negative 9.6666 repeating. So rather than have a run-on decimal or round it and lose my accuracy, I'm just going to leave it as negative 29 thirds. Now I need to check both of these. So I will plug in. We got the absolute value of 3 times 5. Oh, by the way, I'm checking x equals 5 first. Plus 7. Hopefully, plus 11 equals 33. The right side is just 33. There's not a whole lot of change there. 3 times 5 is 15. 15 plus 7 is 22. The absolute value of 22 is 22. Plus 11 is 33. Again, you could type all of this in the calculator. You'll get 33. 33 does equal 33, so x equals 5 is a solution. Then we got to check x equals negative 29 thirds. So I've got 3 times negative 29 thirds plus 7 plus 11 equals 33. Let's see what happens. What's interesting is negative 29 thirds times 3 gives me negative 29. Plus 7 is negative 22. The absolute value of negative 22 is positive 22. Plus 11 is 33. And on the right side, I have 33. And that is a true statement. So both of those are solutions as well.